Okay, so welcome to the first video in a series that I'm going to generate over the course of this year. Essentially, I'll do a video at the end of each week to review what I taught. So this first week with level 1 chemistry, we were introducing you guys to the idea of atomic structure. And what I'm going to do is I'm going to just take one element as an example. So I'm going to take sodium, the element sodium here, Na, as an example. So Na is for sodium. Your version of the periodic table that you get in your exam paper has the elements' names written with the symbols. But if they don't, then you're going to just have to memorize some of these names. And it's only for the first 20 elements. So atomic structure is all about, as the name suggests, the structure of the atom. So through dealing with sodium, I'm going to hopefully cover most of the key terms that we reviewed this week. And it's important that you understand your key terms in order for me to be able to essentially speak the language of chemistry to you guys and progress with our learning. So the first key term we need to talk about is the idea of an element. So the element in question here is sodium. So the element is sodium. That's the one that I've just chosen. The element is known as sodium, and it's a pure substance. So an element is a pure substance with no other elements in it. So if it's pure, then it's just made of sodium. And if it is a pure substance and therefore it's an element, it will be listed on the periodic table. So the periodic table of elements will be given to you in your exam paper, so don't forget that. And this is just a rough little sketch I've made of the outline of the periodic table. There's a little over 100 elements known to man, and it's very tough, as I mentioned in class, to discover any more elements because most of them have been discovered at this stage. The next thing then is, so we've identified that the element is sodium. That's just its name. Now the next thing is the simplest unit, I like to use the word unit, of the element sodium. So the simplest unit of the element sodium would be a single atom, of sodium. So I like to define atom as the simplest unit of an element. So if we take a crystal of sodium, solid, so this little cube represents a crystal of sodium, and it's a solid, so that's what the S stands for, solid. If we could zoom in with a very powerful microscope, we would find that this crystal of sodium, or this solid of sodium, is made up of little units which we call sodium atoms. So they look like little spheres or circles, so we call them sodium atoms. So an atom is the simplest unit of an element. And now, since we're interested in talking about atomic structure, we've now picked our point of focus, which is the atom, and we want to talk about the structure of that atom. Now, like I mentioned in class, the most powerful microscope we have will give you an image which looks essentially like this, lots of little atoms packed together. Now, to see what is inside the atom, or what is subatomic means essentially what's inside or smaller in size than the atom. So inside the atom, there were a series of very famous experiments performed by scientists like Ernest Rutherford, who was from Nelson in New Zealand, Niels Bohr, and other guys as well, who were influential in elucidating the structure, or discovering the structure of an atom. But for level 1, all you guys need to know is what is the accepted model for the structure of an atom. So to help you guys determine the structure of a sodium atom, you need to go back to your periodic table, and we're just going to add some more labels to it now. So on the periodic table, you will find that sodium is in group 1. So the groups go across in vertical columns. Group 1 is there, group 2 is there, 3, 4, 5, so 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 are all in there. And then group 13, 14, 15, 16, 17, and group 18, which is where all elements would like to be. Now, for simplicity's sake, I like to just teach level 1 students that if you look at group 13, if you just consider it as group 3, group 14, consider it as group 4, 15 as group 5, 16 as group 6, and 17 as group 7, and then helium would be in group 8. Because these numbers, the group number will tell you the number of valence or outer shell electrons. So we'll just write that down. The group number is equal to the number of outer shell electrons. And remember, in class I introduced this shorthand for electron as E for electron and negative because they carry a negative charge. So the group number tells you the number of outer shell electrons, also known as the valence electrons. So electron, or plural if you have more than one. So if you're in group 1, you have 1 outer shell electron. If you're in group 2, you have 2 outer shell electrons. Skip over to group 13, you have 3 outer shell electrons. Group 14 will have 4, group 15 will have 5, group 16 will have 6, 17 will have 7, and group 8 will have 8 outer shell electrons, and that's why they're so stable, because they have a full outer shell. So let's take a look at sodium now. Sodium is in group 1, so that tells us it has 1 outer shell electron, group 1. The next thing we need to look at is the row. So rows go across. So this is row number 1, row number 2, and row number 3. So the row number will tell you the number of shells surrounding the nucleus. So the row number will tell you the number of shells surrounding the nucleus of the atom. And the shells are basically those little rings or circles that you draw around the nucleus. And for sodium, we have 3 because it is in row 3. So let's try and draw the atomic structure for sodium. Now there's some other information we need. I'm just going to essentially zoom in on the elemental picture for sodium that you would see on the periodic table. So the symbol for sodium is Na, and then some of you might wonder, why is it not Sd, for example? And the reason the symbol is Na is because the Latin for sodium was natrium, and so they took the first 2 letters and then they gave it the symbol Na. And the atomic number for sodium is 11, and the larger number, the more massive number, is 23. So the mass number, remember I said in class, the mass number is the most massive of the 2. Most massive, so the largest of the 2 to choose from, and the atomic number then is the smaller one. So the mass number tells you the number of protons, which we're going to give the symbol P positive, and the number of neutrons, which we will give it the symbol N for neutron and 0 because it's neutral. So the number of protons and neutrons, because it's protons and neutrons which give the mass of an atom. And since both protons and neutrons are inside the nucleus, then it's the nucleus which gives the most mass to the atom, and then the rest of the space that you see is basically lots of empty space and some electrons which are very, very light. The atomic number tells you the number of protons, P positive, and since all atoms are neutral, if you have 11 protons in sodium atom, then you must have 11 electrons to give it a neutral charge. So that's how you know that the number of protons always equals the number of electrons for a neutral atom. So we have a lot of information now. The atomic number I also described in class. It's like the ID badge for an element, because if you change the atomic number, you've essentially changed the identity of the element. So if you change the atomic number from 11 to 12, and you look up your periodic table, you'll find that the atomic number 12 is for magnesium, which is a totally different element. So you cannot change the atomic number without changing the identity of the element. Okay, so I think we have enough information now to start drawing the atomic structure for our sodium atom. So just to translate the information that we have again, we're in row 3, which tells us we have 3 shells around the nucleus, so 3 circles. We're in group 1, which tells us we have 1 valence or outer shell electron. It has atomic number 11, which tells us we have 11 protons and we have 11 electrons. And then the mass number, which is made up of the protons plus neutrons, will tell us that if we take 23, which is P plus N, and subtract 11 from it, which is for the protons, we get the number of neutrons, which is 12. So we have enough information now to draw the atomic structure diagram. Now what we're going to do is, this is an atomic structure diagram. Also, you could refer to it as an electron arrangement diagram. Now I stress the word diagram because the difference between writing the electron arrangement for an atom and drawing the electron arrangement diagram. So the electron arrangement diagram is going to be a nucleus which has 11 protons and 12 neutrons inside it. So we just write 11p and 12n, put a circle around that. That represents the majority of the mass of the sodium atom, and this is the nucleus. Then we're going to draw our 3 shells because of row 3. So we put our 3 shells around that. 1, 2, just going to scroll down a bit now. So 3, second shell rather, and then the third shell. All right. So we have our 3 shells around that nucleus. Then the next thing we want to do is we want to assign our 11 electrons into those shells. Now there's a basic rule, and this is just based on a theory which is widely accepted. It's taught this way for level 1 and level 2 chemistry. Electrons like to go around in pairs, and you always put 2 electrons in the first shell and then 8 in everything else. That's if possible. So 8 in everything else if possible. So what we do is we like to pair electrons up as well. So we put 2 electrons in the first. Let's just put them right there. 2 electrons in the first, 8 in the second. So we put 2 there. Space them out because they are negatively charged. So you want to kind of keep those charges spaced out. So that's 2, 4, 6, and then we put another 2 in there, 8. So 8 and 2 are 10, which leaves us with 1 more electron because we had 11 altogether. We put 1 more electron in there. Okay, so that would be the atomic structure diagram for a sodium atom. And you have 11 protons and 11 electrons, therefore it's neutral. Now there's another way we can represent that, which is a bit simpler, and that is to simply write the electron arrangement. So if we want to write the electron arrangement for a sodium atom, we want to write the electron arrangement for a sodium atom, then it's simply 2 electrons in the first, comma, 8 in the second shell, comma, and then 1 electron in the third shell. And that would be the electron arrangement for a sodium atom. Then what your exam questions like to do is to introduce the idea that a lot of atoms like to form ions for the simple fact that they want to achieve a full outer shell. Now a full outer shell for most elements will be 8 electrons, except for hydrogen or helium, which just need 2 electrons to be full. Helium has those 2 already, so you'd really just refer to hydrogen forming ions. So in the case of sodium, it's very easy, hopefully, to see either from the electron diagram or from the written electron arrangement that there is 1 rogue electron which sodium should happily lose, and then it will have a full second shell. So this process of atoms losing ions, so if the sodium atom, not losing ions, loses an electron, loses 1 electron, it will form the Na plus ion. So ions are basically charged atoms, and the atom becomes charged because it has lost or gained electrons. Now the reason a sodium ion has an overall positive 1 charge is because the atom had 11 protons. If you remove 1 electron, then it will now have 10 electrons. So therefore you have 11 positive charges and 10 negative charges. So an overall charge of +1 on the ion. That's why sodium ion is Na plus. And then if the electron arrangement for a sodium atom was 281, and we remove that electron, then the electron arrangement for a sodium ion will be 2, 8, and that's it. And it's happy now because it has a full outer shell, where it was unhappy up here. And this is considered more stable. So that's essentially everything that I covered so far in the first week. We did quite a bit, and we actually did almost half of an exam question, which was awesome. So ions are charged atoms, just to complete now and lead into next week. So an ion is a charged atom, and they can be either positive, so that's shorthand for positive. Positive ions are referred to as cations, or negative. Negative ions are referred to as anions. And we'll have more focus on ions later in about a week and a half. But for next week, we're going to take a look at the atomic structure, just like we did for sodium here. You guys have to be able to reproduce that information for the first 20 elements from the periodic table. So that's the focus for next week, and that will be next week's video in review.